Hello, welcome back everyone. Today we are diving deep into the world of predictive analytics with machine learning. In our previous lessons, we have explored the basics of data analysis and delved into the power of machine learning. Now we are taking it up a notch with predictive analytics. Have you ever wondered how companies predict customer behavior, stock prices, or even sports outcomes? Well, it is all about leveraging the predictive power of machine learning algorithms. From predicting the weather to optimizing supply chains, predictive analytics is everywhere. In this lesson, we will unravel the secrets behind making accurate predictions using cutting edge machine learning techniques. Machine learning is not just a technological advancement. It is a dynamic and rapidly expanding field under the expansive umbrella of artificial intelligence. As Arthur Samuel eloquently put it in 1959, machine learning gives computers the power to learn and evolve. Think of it as empowering machines with the ability to decipher the hidden patterns within vast datasets, enabling them to make informed decisions autonomously. Machine learning is fundamentally about teaching computers to evolve over time as they analyze and adapt to patterns and insights in data. They become increasingly adept at making accurate predictions and informed decisions. Practical applications of machine learning are as diverse as the technology itself. It is a driving force behind groundbreaking advancements in natural language processing, enabling computers to understand, interpret, and generate human like language. Look around, and you will see the magic of machine learning at play in computer vision. From facial recognition to image classification, the technology allows machine to see and interpret visual data with incredible accuracy. Let us talk about real world scenario. Imagine a self-driving car effortlessly cruising down the road, making split-second decisions based on continuous data stream. That is the power of machine learning in action. But that is not all. Machine learning can be used to avoid fraud. Its ability to detect anomalies and patterns makes it crucial to safeguarding our digital transactions. Whether it is securing your online transactions or protecting your sensitive information, machine learning is there tirelessly working behind the scenes. Think about your favorite streaming platforms such as Netflix and Amazon. Ever wonder how they know exactly what shows or products to recommend? That is the brilliance of machine learning in online recommender systems. As you binge watch your favorite series or explore new products online, machine learning algorithms analyze your preferences, predict your likes and dislikes, and tailor recommendations just for you. But there's more. Machine learning is also the force behind sentiment analysis. It deciphers the emotions and opinions expressed in online content, giving the business insights into how people feel about their products and services. Picture this: business understand public sentiment in real time, adapting strategies based on the market's pulse. That is the game changing impact of machine learning in sentiment analysis. Machine learning, in simple terms, is like teaching computers to learn from examples and make decisions or predictions on their own without being explicitly programmed. For example, in the context of cat and dog image classification, involves training a computer algorithm to recognize and distinguish between images of cats and dogs. The computer is trained to recognize the distinguishing visual characteristics of each animal. This process uses supervised learning with labeled images used to train the model to make predictions on new, unlabeled data. The accuracy of the model depends on the quality of the training data and the algorithm's ability to find patterns in images. To put it simply, machine learning involves training computers to learn from past experiences and make intelligent decisions based on that learning. It can be compared to teaching a pet to do tricks by demonstrating the desired behavior. In machine learning, the concepts of training and testing are fundamental aspects of model development and evaluation. During the training phase of machine learning, the main objective is to teach the model to identify patterns and relationships within the given data set. This is achieved by exposing the model to be a labeled data set where features are associated with their corresponding labels or target variables. The algorithm then iteratively adjusts its parameters to minimize the difference between its predictions and the actual labels. The outcome of this process is a trained model that can make accurate predictions on new unseen data. In the testing or evaluation phase of machine learning, the objective is to assess how well the trained model performs on new unseen data. The model is presented with a separate testing data that it hasn't encountered before during training. The model makes predictions on this new data, and the predictions are compared to the actual known labels. The outcome of this process is the calculation of metrics such as accuracy, precision, recall, F1 score, and etc., which provide insights into the model's ability to make accurate predictions on real world unseen data. The fundamental concept behind dividing data into training and testing sets is to evaluate the model's capability to make accurate predictions on new unseen data. The ultimate objective of machine learning model is to perform well in real world scenarios, and testing it on a distinct data set aids in assessing its ability to do so. The training and testing process is crucial in evaluating machine learning models' performance, robustness, and generalization capabilities, which ensures that they can make dependable predictions on new unseen data. Imagine possessing a complete dataset. The training set, constituting a substantial portion, is utilized to train a machine learning model, usually encompassing around 70 to 80% of the dataset, though the exact ratio may vary. During the training phase, the machine learning model derives insights from this dataset, discerning patterns and relationships and features to construct a predictive model. The model refines its parameters to align with the training data accurately. Conversely, the testing set, also called the validation or holdout set, constitutes the remaining portion of the dataset excluded from training, typically making about 20% to 30% of the total data. This testing set serves the purpose of evaluating the model's performance post training. The model applies its acquired knowledge to make predictions or classifications on the testing data, and its effectiveness is assessed by comparing these predictions to the known outcomes or labels in the testing set. Now, let's move to the next topic: machine learning techniques and models. Machine learning techniques are methods, algorithms, and approaches that help computers learn from data, identify patterns, and make predictions. These techniques are categorized based on the type of learning and tasks they perform. The main tasks of machine learning include classification, which is a supervised learning technique used to categorize data points into predefined classes or categories, and clustering, An unsupervised learning technique used to group similar data points based on their intrinsic characteristics or similarities. The objective of classification is to create a model that can predict new data labels based on the patterns and relationships learned from the labeled training data. On the other hand, clustering aims to find underlying patterns or structures in the data without prior knowledge of class labels. The two techniques, classification and clustering, are both useful in different ways. And the choice of which one to use will depend on the specific problem as well as the availability of labeled data. Machine learning is an essential tool in the field of predictive analytics. Predictive analytics can forecast future outcomes by utilizing historical data in combination with statistical modeling, data mining techniques, and machine learning. This technique has applications in various industries, such as finance for credit scoring, healthcare like disease prediction, marketing in customer segmentation, and also in manufacturing for predictive maintenance. Moreover, it enables organizations to make informed decisions, optimize processes, reduce risk, and gain a competitive edge by leveraging historical data to anticipate future outcomes. Here you can see some examples of machine learning models. There are random forest, gradient boosted model, generalized linear model, support vector machine, K nearest neighbor, naive Bayes, decision tree, artificial neural networks, and logistic regression. The machine learning process involves several key stages, each playing a crucial role in developing a successful model. First, input data. Input data is the raw data on which the machine learning model will be trained and tested. The input data typically includes features or variables the model will use to make predictions or classifications. Next is data preparation. The purpose is to focus on preparing the data for the machine learning model. It can involve two steps: data preprocessing, attribute selection. The first one is data preprocessing. Data preprocessing involves cleaning and organizing the data to handle missing values, outliers, or inconsistency. Then we do attribute selection when we choose the most relevant features for the model, as too many or irrelevant features can impact the performance of the model. The third phase is predictive model. This is the heart of machine learning process, where a model is created based on the prepared data, choosing an appropriate algorithm based on the nature of the problem, for example, classification or regression. Then, using the training data to teach the model to recognize pattern and make predictions. Not only that, you need to do parameter tuning to adjust the model's parameters to optimize performance. And lastly, is the output. The ultimate goal is to obtain meaningful insights or predictions. We can represent the results in a user friendly format, such as dashboards or visualizations, enhances the interpretability of the model's outcome. In summary, the machine learning process begins with raw input data, goes through a thorough data preparation phase, move on to building a predictive model, and concludes with the output, which can take various forms depending on the applications, including predictions, performance metrics, or visual representations. Each stage is crucial for developing a robust and effective machine learning solution. A naive Bayes model is a simple and efficient machine learning algorithm for classification tasks. It is based on Bayes' theorem and assumes that features or attributes used for classifications are independent, which is why it's called naive. Despite this simplification, naive Bayes performs surprisingly well in various applications, including spam email detection and object classification. Let's look at how naive Bayes might be applied to classify apples based on specific attributes. Imagine we have a data set with features like color, size, and texture, and we want to determine whether a given apple is of type A or type B. Features we considered is color for feature 1, it can has green, yellow, or red. Shape, which is the features number 2, could be round with medium, small, or large sizes. And diameter, it could be 3 inches. The model learns the conditional probabilities of each feature given the apple type. For example, imagine we have a new apple with the following features. It is red in color, medium size, and the diameter is 2.5 inches. The naive Bayes model calculates the probability of this apple being type A and type B based on the trained probabilities of each feature. If the probability of being type A is higher, then the model classifies the apple as type A. Now, let's explore the concept of a decision tree. A decision tree model is a clear cut and comprehensible machine learning algorithm applicable to classification and regression tasks. Its methodology involves iteratively dividing the dataset into subsets based on the most impactful attributes, ultimately culminating in a prediction or decision. Decision trees are esteemed for their straightforwardness and interpretability. They allow users to grasp the decision making process and significance of different features in shaping predictions. Next is the neural networks. A computational model inspired by the human brain structure and function is called a neural network. This machine learning algorithm solves various tasks such as image recognition, natural language processing, and game playing. Neural networks are incredibly flexible and can learn complex patterns from massive datasets. They have revolutionized many fields of artificial intelligence and are still being used in cutting edge research. In machine learning, typically a neural network consists of multiple layers of computational units that are interconnected in a feed forward way. In many cases, the units of these networks apply a mathematical function known as an activation function. After creating the machine learning models, the next step is to evaluate their performance. Model evaluation involves assessing the quality and effectiveness of a machine learning model using various metrics and techniques. It is a crucial aspect of the machine learning workflow as it helps determine how well the model will perform on new and unseen data and whether or not it fulfills the desired objectives. Model evaluation guides model selection, hyperparameter tuning, and overall improvement of machine learning systems. It ensures that machine learning models meet the desired performance standards, are robust, and can be trusted when making informed decisions across different domains and applications. In the world of machine learning, practitioners often experiment with multiple algorithms or different variations of a model. Model evaluations plays a significant role in selecting the best performing model among the alternatives, especially in real world applications where the performance of a machine learning model can have a considerable impact on business outcomes. Model evaluation helps in assessing the potential benefits and risks associated with deploying a model in a particular context. Some examples of model evaluation metrics include accuracy, precision, recall, F1 score, confusion metrics, receiver operating characteristics or ROC curve for classification, for clustering. Silhouette score, elbow method, and Dunn index are some common metrics used for model evaluations. As we conclude lesson 3, I hope you've had a great time exploring the fundamental concepts of data analytics with us. Our journey has taken us through the core principles from comprehending the intricacies of data to decoding the power of predictive analytics. Bye.